Alrighty, I guess we'll go ahead and get started. So my name is Drew Wallis, and I am the Director of Sales and Education for NWA3D. So we're a 3D printing company that's partnered with East to help all of y'all with 3D printing. So before we get too much more into it, I'd like to see a raise of hands who has a 3D printer in their East class. Okay, awesome. I was hoping that a lot of people would, and if you don't, that's totally fine too. This will still be helpful because we're going to talk about a bunch of different stuff that pertaining to 3D printing. But I was hoping that a lot of people would have 3D printers in their class because we're going to talk about some kind of more advanced things with 3D printing and different things to go through. So the first thing that we want to talk about when you're trying to make a project that has to do with 3D printing is to realize that 3D printing is a tool. And it's not going to be this thing that you use for every single project. And 3D printing is awesome. Don't get me wrong, but it's not going to be something that every single fix is going to be able to be made with a 3D printer, because a 3D printer is only one tool in your toolbox of East. So there might be something that would be better for you to use like woodworking with. Or there might be something better to use, like find somebody with a CNC machine or a laser cutter, or maybe it's something that would be even better as like a website or a graphic design like poster that you make in Adobe Illustrator or something like that. It might not always be something that is going to be able to 3D print with it. So you have to think about the different ways that 3D printing is going to be used. And it's not going to cure every single project and every single thing that's going on, because it's only like one of the many awesome things that you guys have to use. So the biggest way that you can help think about how to incorporate 3D printing into a project is to know how it works. So who can explain in like a sentence like what a 3D printer is? What do you think? Go for it. Yeah, you, and then you can follow it.
It's like instead of like on paper and then just in real life and you print it.
Yeah, totally. It prints it in real life instead of just on flat.
And it prints
What do you think?
like 3D models of it.
Puts 3D.
3D models instead of like flat, like say you would have put a hat, it doesn't print a picture of a hat, it prints like where you can like feel it.
Yeah, exactly. What do you think?
It's a hot glue gun for plastic.
Exactly, yes, totally. All three of you are right. It's like a hot glue gun that's going to print out stuff with plastic filament. Or it doesn't have to be plastic, but most of the time it's plastic, into your 3D shape. And how does it make stuff in 3D? Like, what does it do to make stuff in 3D? Like, how exactly does it work? What do you think?
It uses a 3D model that someone has made.
It uses a model from a computer, absolutely.
Follow a code.
It follows a code. What do you think? It uses filament. What's it do with the filament when it makes the model? Because if it just like printed it, it might just look like a flat thing on a piece of paper. So what's it have to do with the filament? What do you think?
It melts it and then it follows certain correlations on the building plate to make it.
Yeah, exactly. So what kind of coordinates? Like, how is it moving around? So it melts it down.
X, Y, and Z.
X, Y, and Z, yeah. So it moves around side to side, and then the big one is up and down. And that's that Z coordinate, that layer by layer by layer shape of how it's going to create something. So that's the first step when you're thinking about making something that's a 3D printed project with East. You have to think about, is this going to be something that we can use with a 3D model? And is it going to be something that we can like move forward with if you're going to be able to make a model for something? So that might be a prosthetic hand, that might be a map of somewhere. Like I've seen some awesome topographical maps that people have made. There's so many fantastic things everywhere from, like there's so many sweet projects that are around here. By just walking around, you can see that there are lots of different uses for 3D printing. Everything from a fix where you might repair a chair, all the way to like changing somebody's life forever. And there's so many things under that, but it might not be something that has to be made with a 3D printer. And knowing exactly what a 3D printer can do is also going to be really successful with trying to figure out what's going to be the best. And the next thing that we're going to talk about are the 4 biggest issues that arise from an actual 3D printer. So once you know you want to use a 3D printer for something, and you know how the technology works, then we have to work through the 4 biggest pitfalls that happen with 3D printing. The first one is making sure that the filament is going through your printer correctly, because it has to melt that filament down layer by layer by layer by layer into your shape. So you have to make sure that it's loaded, you have to make sure that it's not clogged, and all those different things. So clogging and filament issues, that's the biggest step. That's one of the 4 biggest things that happen. And if it's clogged, one of the awesome things that you can do to unclog it is to always take the filament out when you're switching the filament when it's only at 100 degrees. Not all the way up to the heated temperature like you would normally melt stuff. And that's called a soft removal. So when you take the filament out when it's at 100, so you basically say, you tell your printer to preheat or change the temperature of your printer to 100, and then squeeze the little lever on the side and pull the filament out when it gets to 100 degrees from a cooled off state. And then what that'll do is that'll pull out the filament when it is kind of liquid and kind of solid and right in the middle of that. So you pull that out and it will pull out like this blob of stuff, because things that can cause 3D printer clogs are like dust, just being in the classroom. It can be parts of plastic that get hardened in there. And one of the big things too that happen is the heat can creep up inside of where the gears and stuff are, and it can get above where the heating area is. Because imagine it's like a funnel, and that funnel is really heated. But if the filament gets hot above the funnel, then it's not able to push it down inside of the funnel. So above that, if that gets really melted, then the gears can like dig into it and it can make like that half moon shape. Or it might not push anything in at all because it's trying to push it into the top and it's getting stuck. So doing a soft removal when you change filament is one awesome way to fix it. Another awesome way to fix it is, by turning the heat up to about maybe 250 degrees and then letting it sit for like 5 or 6 minutes and then pushing the filament through. So holding that knob down and then trying to force the clog out. So instead of pulling the clog out like a soft removal, we're trying to force the clog out. And then when you force the clog out, if it's still not coming out, then turn the whole thing off, and then turn it back on and try to do a soft removal again. And if that doesn't work, and you should be able to pull it out. And when you pull it out, once you get the filament out of there, if the clog, you still think it might be clogged, you can use a filament unclogging tool, which is like a little wire that you can stick inside of there. And we have some at our booth in the Tinker Space down at our 3D repair booth. So if you bring your 3D printer down there for advice, and you can hang out and we'll walk you through some things to work on your 3D printer. We have those nozzle cleaners down there, and we'll give you guys one. So you can clean it out and be able to basically floss out the stuff that can be inside the nozzle. You can like hold onto it with a pair of pliers and you can kind of clean it out. And then you'll load the filament again and try to push it out. And what we're going for is to not have to take it apart. Most of the time, you don't have to take apart the extruder assembly to get a clog out. You can do it by doing several soft removals and doing like forcing the filament out and then using the flossing tool. That will get out like 99% of the clogs. You shouldn't have to take the extruder all the way apart. And another thing that you can always do to prevent the clogs from happening is to make sure that you don't ever leave the printer heated and on and not moving. Because the filament will bake inside there. And I mentioned a little bit ago how the stuff will like creep up in there. It will creep up into where the gear is, and then because it's getting soft, the gear will like dig into it, and then when the gear digs into it, especially if it's just sitting there for a long period of time, it can like bake it all inside of there. And the filament can get baked in and can get really hard to get out. So to prevent clogs, it's good to do a soft removal with 100 degrees and to use to not leave it on and heated and not printing. Because that's what the heat can all just like creep up inside of there. So that's the first big thing with 3D printing. The second big thing is that it might sound really simple, but sometimes things can come unplugged. So it's usually the first thing to check. If something's not doing what it's supposed to be doing, if it's making sounds like a dying transformer, like and moving around and making all kinds of crazy noises, just check all the little plugs. So every 3D printer has motors and little switches that click. And those little switches that click on there, those are from the 0 coordinates on X, Y, and Z. So when it goes to X, Y, and Z, it zeroes out with those little switches. And sometimes those switches can come unplugged, and that can cause problems. So make sure that the switches and the motors are all plugged in. Especially if it's moved around a little bit, or if it's been working and all of a sudden it just stops and you can't figure out why, then that could be it with that one. And then the third thing is making sure that the build plate is level. And that one is the toughest part of 3D printing, is trying to make sure that the build plate's all level. So a lot of 3D printers, they have manual build plates where you're going to do it. And you use a piece of paper or fold a piece of paper to level it. That's how most of our printers are, where you level it manually and get it all set up yourself. But there are other printers, though, that have automatic leveling features that are a little bit more difficult because sometimes they might not work exactly like they're supposed to. So the best way to help fix one of those printers, if like so let's say you go through the auto leveling feature on it and you see the little light sensor going on and it's moving around, and then it starts to print and it kind of is in the air and it's kind of like spaghetti, kind of gooping out all over the place. That means that it's a little bit too high from the build plate. So what you can do is on like some of the large printers that you can reach in really, really carefully, you can adjust some of the nuts and be really careful to not get caught in any of the motors as it's moving up and down. But you can adjust the nuts a little bit until you have that good first layer, until you see it sticking down. Because imagine that first layer like toothpaste on a toothbrush. So if you are like jamming your toothpaste into the toothbrush and you squeeze it, it's gonna like push the bristles out of the way and it's not really gonna go in there. But if you're holding it in the air and you squeeze the toothpaste, it's gonna just like go all over the bathroom sink and it's not gonna go anywhere where you want it to go. But if you have it on the toothbrush and you're squeezing it on there, then you'll have that bead of toothpaste that gets on there. And that's what the 3D printer has to do, because it has to layer it, layer by layer by layer. So having that together to make sure that all those beads are sticking together is what the leveling process is all about. It's basically telling the machine exactly where 0 is, so it knows where to start. And by adjusting a little bit while it's going, that sometimes on those automatic ones, that's how you can get it to be level. And then go ahead and stop the print and then clear all that stuff off and then restart it again. And then hopefully it'll be level. And that's one of the things that can help for the automatic leveling ones that might not be level like they're supposed to be. And then the other ones, you just want to use tension with a piece of paper. So you either use a piece of paper if you're using tape, or a folded piece of paper if you're using like a build tack sheet or a lock build like we have. Then you fold that piece of paper and then you want to feel it dragging underneath each one. You'll put it between the nozzle and the paper and then the little screw on the bottom. And you make sure that when you drag it around, you can feel that tension on each one of those. And then you kind of move it around to make sure it's level. Because if it's too high up in the air, it's going to turn into spaghetti, or it might knock your model off and be moving around. And if it's too low, it'll like dig into it and dig stuff apart. And then the fourth big thing, that has to do with your slicer. So, uh-oh, weather alert. All of our phones are probably about to go off then. That one's going off. So, with the fourth one is the slicer. So does anybody know what a slicer is? To me when I say slicer. What is that?
Like, we have Cura, and
Yeah.
it's like our slicer, and my friend told me it's like, it slices the model of the code, and when you print it.
Exactly, yeah. So what's another slicer? Cure is one. It slices the model and code. What's another one?
We use matter control.
Matter control, that one works. Yep. Anybody know of another one? Megabot desktop, that's a slicer. Same thing. Could you put your model in it? Simplify 3D is another one that's out there. Flash print, that's another one that uses, that you can slice stuff with. We like Cura because it's open source. And it's awesome, and you can do all kinds of different types of printers with it. And I think on Matter Hackers you can put a bunch of, or Matter Control, you can put a bunch of stuff on that one too. I believe you can put a lot of different printers and things on there. And we like those slicers so you can do multiple machines. And basically the slicer tells the printer what to do. So if those settings are wrong, then the printer's not going to print it. And then your project's not going to be able to work because the settings for the control of the machine are not correct. So one thing that you want to do is make sure that if you're printing with PLA, you want to print at 220 degrees. So sometimes it might tell you to print a little bit less than that, and if it's less than that or more than that, sometimes that can cause clogs. So usually 220 degrees is a really good place to start with printing with PLA. And then the next thing that you want to do is make sure that your speed is 30 millimeters if you want it to be high quality, 30 millimeters a second, or about 50 millimeters a second if you want it to be like medium quality. And if you go too much over 50, by setting those different parameters, it can go like all over the place and it can kind of mess up the printer and it might not be working exactly like it should be. So that's something to keep in mind too, is making sure that those two settings can help a lot of different things. So making sure that both of those settings are right, because if it's going too fast, then it's not going to be able to stick. The filament's not going to stick to the plate before it moves to the next thing. And then that can cause things to peel up and things like that too. So that's something to keep in mind. So with those different slicing errors, that kind of moves us into the design part. So when you want to troubleshoot your design, that's the next step. And Cura is a part of that. Yeah, what do you think?
What was the second problem?
The second one was making sure everything's plugged in. So yeah, we'll go over the 4 problems again. So first, make sure that everything is like not clogged in your printer and your filament's loaded in. And the way that you can prevent that is by the soft removal and making sure it doesn't stay on and heated and not printing. And then the second thing is making sure everything's plugged in. So all the little white plugs are plugged into all the motors and switches. And sometimes the plugs might be black, sometimes they might be gray, but they go into all the little switches and make sure everything's plugged in like it should be. And then the third thing is making sure the build plate's level. And then the fourth thing is making sure that your settings in your slicer are correct for your printer. Because it also, if you're trying to print for, let's say you wanted to print on one of the huge printer, but you're trying to slice for the small printer, then it's going to try to print the giant model on the small printer and it's not going to work because it doesn't know the correct sizes of it. So you have to make sure that you have the correct settings for your particular printer, for your specific printer that you're printing with. So especially if you have more than one different type of printer, like if you're switching back and forth between an Ultimaker and a printer bot, or a printer bot and one of our NWA3D5s, or a MakerBot and one of our NWA3D5s, and like going back and forth, you got to make sure that your settings are right for your machine. Yeah.
Like when we use Cura on ours, it doesn't have it. We have I think we bought it from NWA3D. But it's like a
What's free? Just
bot.
included it.
I think it's just like that.
Yeah. So we can help
But it
you.
doesn't have that on like Cura, so we just use the Ultimaker size.
So I can help you with that.
It prints fine.
If you come talk to me right after class, then I'll share a video with you, because we have a video on how to install it for our 3D printer, for our NWA3D5, that you can watch. So they'll walk you through all the steps, because you have to make sure the steps are correct, because if it's going too fast or printing in a different way, then it might not print right. So yeah, come talk to me as soon as class is done, okay, and I'll give you that. So, making sure that design is together, and part of that slicing and Cura errors can be print orientation and print methods. And that's the first thing you have to think about when you're making a model. So no matter what type of model you're going to make, you got to think about, like, how is this thing going to print? So if you're trying to make a prosthetic hand, let's use that as an example. You might not be able to print the whole hand all together at the same time. So what will you have to do? Exactly, yeah, you got to split it up. You got to put it in a bunch of different types of parts. And maybe it's the same thing, like if you were going to make, let's say you're going to make a stand to hold a camera up or something like that. That might be too big to be able to print as like one solid piece. So you can split it up in like all those different parts. And you got to think about that when you're making your design too. So no matter what CAD program you're using, you got to think about how you're going to actually, how this is actually going to print. So how is my model going to be printed? So once you know that you have a good model, you got to think about how it's going to be printed. And that has to do with maybe where you need to split it apart. And are you going to glue it together? Are you going to make it screw together? Because there are some things that you can do to put like a nut or a bolt where you can kind of like screw it in there. Or is it going to fit together? Or are you going to glue it? Or are you going to use like to fuse it with plastic from some way by like melting it? Or like how exactly are you going to get it to stay together to make your model? And the other thing that goes in with that is print orientation. So that, does anybody have a guess about what that might mean? What do you think?
What way it's facing?
Yeah, like what way your print's facing. So when you put your model, we'll just keep going back to the prosthetic hand. So let's say you were going to print your hand in Cura, and you take your model and you put it inside of Cura. Well, it might be, let's say your model is sitting in Cura like this, and like all the fingers are down like that. So when you're thinking about that, what's some error or something that could arise from having like a bunch of small parts touching down, and then you have like a larger part on top? What do you think? Let's raise our hands so I can call on you. What do you think?
Could it like start spaghetti on the bottom of it?
It could spaghetti. Yeah, because it might not be able to stick because it has like small areas that are stuck to the build plate because it needs to get a firm stick on that build plate. So that's definitely something that can happen. What do you think? Yeah, the bottom parts could break off, and that kind of goes in the same way of making it kind of weak. Absolutely. What do you think? Like when it's moving? Yeah, it could totally do that. What do you think?
It'll fall over.
It could fall over? Yeah, because it might be too heavy on one side or another. You got something?
I'm gonna say warp. Like that.
It could warp up. Yeah, so, and that's the thing too. I'm glad you brought up warping. So to prevent warping, there's a couple of really good things that you can do too. And that's also with print methods and how you can work with that. So with your model, instead of printing it, let's say it had a bunch of intricate parts, instead of printing it like this, maybe you should flip it all the way around so it prints up like that. Because then the big flat part will be on the bottom, and it'll be able to stick to that, and then the small delicate parts will be going up, and then they won't need supports either. Because if you're printing like this, it's going to need to print supports, like inside of my hand. It would have to print supports to be able to get that to work. Or otherwise, the whole thing just might collapse if you didn't put supports in there. But if you flip it over, so the intricate parts are on top, and the flat area is on the bottom, then that can help for a lot of the different types of prints. And when you're printing something, then you won't have to spend a whole bunch of time like cleaning up all the supports and all the different types of things. And if you're having problems with warping, the two biggest things that you can do to help prevent warping is one, making sure that the build plate's level. Because if it's too high, then the plastic isn't sticking together well, so it's like curling up as it's going around. And then the next thing is to print with what's called brim. And brim are basically suction cup lines that go around the outside of a print. Has anybody heard of brim before? Maybe you heard of it? Yeah? So brim is awesome, and it's basically like lines, like 4 or 5 lines that will butt up to the end of your model, and they'll print on there, so when the model tries to buckle up, the brim will be stuck on there, and it won't let it peel up. You can also print with a raft, too, but we don't really like printing with rafts because we think rafts just waste a lot of plastic. and they waste a lot of filament that you don't really need to use. So you can print a raft though. If you wanted to print something that was really intricate, you might want to print it as a raft just to help it out a little bit. So you can, sometimes it might be good to print with a raft if you have a really intricate model that you need, and it will buckle on the sides of the raft instead of on your model itself. So sometimes you might want to use a raft, but most of the time you won't have to. So print orientation is something that you definitely have to think about. And the next thing that you have to think about is the safety of your model and how your model is going to be used. So if you're going to make like a carabiner for like a rock climber or something like that, you have to think about that for a long time before you would trust to be like held up with your body weight on this like hook that's going to hold up somebody's weight. Or if you're going to be hanging plants like in your classroom, you got to think about the hooks that you're making, and you got to make sure that they're designed with enough integrity to not collapse and to not get somebody hurt. So you have to think about if you're going to be doing something where there's a possibility of something falling or somebody getting hurt, you have to think about that safety aspect of your design. So especially if you're going to make something that's going to be hanging off something else or something like that, you have to think about maybe the infill that you use. So does everybody know what infill means? What's infill?
The inside fill.
Yeah, totally.
Like you make it hexagon.
The hexagon stuff, yeah, it's that inside stuff, that like crosshatch pattern, that like back and forth pattern that's inside of models. So you might want to turn that up. And a lot of times, like you can make something solid like 100%, but making something like 50% filled in will make it really, really durable and really strong. But if you wanted to go all the way up to 100, you can. It'll just use more filament, things like that. But it depends on what you're making, because if it's going to be something that's hanging, maybe it needs to be 100% to make sure that it's going to be strong enough, to make sure it's going to be able to hold. So that's something just to keep in mind, because if you make it something where it doesn't have a whole lot of that infill, that could cause problems. And also another thing are a shell. The shell is the outside part of the model itself. So it's like your skin. Imagine your skin. And that outside skin of the model has to be thick enough for it to be able to work. So with that, you want to make that a multiple of the nozzle size. So a lot of times you want to have like more than one shell. So most people will have, if you're using 1.75 filament, which most 3D printers do, then you'll use like, make sure that the shell, and this is in your slicer setting, is set to 0.8, and that means 2 shells. Or 1.2, that would be 3 shells. And then you can see like the multiples as it's moving up. So then you'd have, the next one would be what? 0.8, then 1.2, how'd you get to 4 shells?
1.6.
1.6, there we go. So that's how, and 4 shells would mean the outside of your model is going to be really strong. And that would be something, especially for safety concerns, is to make something that's going to be really tough and durable and strong. So you can think about those different things as well. And if you have an Ultimaker or Lulzbot, then you have like 2.85 filament or 3mm filament, and those, they have to be a multiple of 0.5 because your nozzle's bigger. So your nozzle's 0.5. So then that would have to be like 0.5 for one shell or 1 for a shell. And as you're moving up, because it's a multiple of that nozzle, and as you're working through. So that's something to keep in mind, like as you're going back and forth with everything. Another thing to keep in mind is what CAD program you're using to make sure that it is solid. So if you design something in not a traditional CAD program, you might have to make sure that it's all connected together so it can print, so the slicer can read it. So if you make something in like Autodesk, if you make something like Inventor or Fusion 360 or SolidWorks, or Tinkercad, or Onshape is another really awesome one that's free in a web browser. If you make something in one of those, then most of the time those are CAD programs, and they're designed to make everything touching and everything connected and to be a solid model itself. But if you make something in SketchUp and you don't have like the STL extension and you're making stuff, or if you make something in Blender or in Maya or a program that's not traditionally used for 3D printing, you might have to do an extra step to make sure. So like you can get that STL extension in SketchUp, and that can help stuff to be able to 3D print from it. And then the thing that you want to do with Blender and Maya, there's another awesome program that's out there. If you want to design in Blender or Maya, it's called Mesh Fixer. And that makes everything solid on a solid mesh. So has anybody heard that before, that term mesh? Mesh, what's it mean? What do you think? What's it mean when I say mesh?
Like, all stick together.
Like,
Stick together, yeah? What do you think?
So in photogrammetry, when you take 50 to 80 photos, put it into mixer, the mesh is the
And it can create that meshes your like the model itself. Yeah.
So it basically connects everything?
Yes, totally. It connects everything together. So imagine, let's say we're making like a cube in Blender. And you made, like, the walls of your cube, you made them to stand together like this in Blender. Well, in Blender, these things are touching, but they're not connected. They're just touching. They're just there. So in Mesh Mixer, when you put it in Mesh Mixer and then say make solid, it looks at your model and it's like, oh, okay, these are touching, then they need to be connected. So it connects them automatically. So if you have models that just collapse in, or they're parts that don't print, or you put it in a slicing program and you don't see your whole model, that's the biggest hint that something is wrong with the mesh. It's like, you made, let's say you made this awesome tree, and then you put it in Mesh Mix, or you put it inside your slicing program like Cura, and then you don't see the tree at all, even though you loaded it in there and you don't see it. That means that it might not have a solid mesh because it has to read the solid mesh to be able to slice the file. It has to be able to read it, to do that layer by layer thing. So that's the third thing. And the fourth thing, and the biggest thing that has to do with designing for 3D printing ease projects, is to make sure that all of your stuff together is measured right. So, ever heard of measure twice, cut once? Ever heard that term before? Yeah. Anybody who's worked with like woodworking and stuff like that? It's the same type of thing with 3D printing, only it's measure twice and print once. So make sure you get all your measurements right using like a digital caliper or a ruler, but digital caliper is probably the best to be able to try to get that exact measurement on something. And it'll show you the measurements, but then on your actual object that you want to do. So like, let's say you're going to make a cup holder that was going to sit on there, and you wanted to make it large enough to fit like a soda bottle. Well, you need to measure the soda bottle to make sure it's going to be a big enough like sphere or a big enough circle for it to fit inside there. So you have to measure that so it'll fit inside that cylinder. You have to make sure that size is correct. Because if you print something out, and I'm sure some of you might have printed something out and then it didn't fit like it was supposed to. Anybody do that before? Print something out and not fit? Yeah, a couple people. I've totally done that a lot. Yeah. So like printing something out and then it doesn't fit, then you got to go back and measure it again. That's part of the design process, and it's totally okay to do that. That's part of it, and it's totally awesome to fail. And what's important is from that failure is learning from that. And learning from your mistakes and then moving forward, be like, well, why did this fail? What happened? Was it something wrong with my model? Was it something wrong with the slicer? Was it something wrong with the printer? And trying to problem solve those things can be really tough. But a lot of times the measurements that's the first thing to step. And make sure, the first step to go through is make sure that those measurements are all set up like they're supposed to be. So once you have all those different measurements and things like that, oops, sorry about that. We want to think about, we want to think about different materials that you might want to print with. So there are lots and lots of different stuff that's out there, different types of materials to print with, but the main thing is, again, knowing what a 3D printer can do and what types of files and stuff it can make. Most of the time, for like 90% of the projects and stuff that you'll be doing, you can probably use PLA, which is polylactic acid. And it's made from corn sugar, and it's biodegradable, and it's not toxic, and it'll hold up really well for anything that's going to be inside, or anything that's going to be taken care of, like inside, or that somebody's going to use that's not going to be outside. If it's going to be outside, then you might want to think of other types of materials to use. Or if it's going to be something that needs to be bendable and flexible, then that might be another type of material to use. But most of the time, you're going to be using PLA, and PLA will work for nearly everything. But if you want to print with other materials, you totally can, but it's a little bit more difficult. Because another thing that's really nice about PLA is easier to print with. But if you want to print with something like ABS is the next one. If it's going to be outside, you could print something with ABS and it'll last longer than PLA, because PLA will biodegrade, it'll break down after a while. But ABS, you have to make sure that it's a really well ventilated room because the fumes are toxic. And you also want to make sure that everything is calibrated right on your machine because it's harder to print with. So it'll buckle a lot more, like as it cools, it'll warp a lot more than PLA, and it's a lot more harder to print with. So that's something to keep in mind, but it'll last because it's a little bit more durable and sturdy than PLA is, so it'll bend a little bit more. So that's why bridges aren't made out of iron, because if bridges were made out of iron, they would just snap because iron's brittle. So that's why they're made out of steel, because steel has that little bit of bend in it. And that's kind of like ABS versus PLA too. So there are PLAs though that have some extra materials in it. And if you have PLA from us, from Push Plastic, that's the company in Springdale that makes our PLA. They have an extra ingredient inside there that makes it more flexible and bendable. So a lot of it even helps for even more applications that you normally wouldn't make PLA stuff. It's not nearly as brittle as regular PLA, so it's awesome. So if you have that, then you're good to go. But even a lot of other types of PLAs are starting to have those extra ingredients and things in them to help you, so you don't have to print ABS, because ABS is just hard to print with. And then the next thing that you might want to print in would be TPU, or Ninja Flex, or flexible material. And that one's a lot harder to print with. And the thing with the flexible materials is you might have to do an upgrade for your printer. So it might not be something that you can just immediately print with and just like, all right, here's the settings and then go. That's the one where you're gonna have to worry about all the settings that you gotta do and all the different things back and forth to make sure that everything on your slicer is correct and your printer too. Because some printers you might have to modify to be able to print with TPU. You might have to put a bigger nozzle on it, which you could absolutely do yourself. Or you might have to change the way that the extruder feeds in so it doesn't like bind up and turn into this giant like mess right where the gear is. Because it's basically trying to push rope through a garden hose when it's trying to push that, because it's really bendy and it's all wily and wiggly and you're trying to push it through like a tube to get it into the printer itself. So you're trying to like push that around and the printer's trying to do that, but if it's not going out, if it doesn't have a good amount of pressure, then it's just gonna bind up and it can like get clogged and it won't push through. And then it can bake in your extruder and things like that can happen. So it's a little bit more difficult to do and you just gotta change some of your settings. And then the next material that you wanna think of about PLA composites. So those are things that are mixed with PLA. So they have graphene. If you wanted to make a circuit, you could print a circuit with PLA. And you could do, like there's magnetic PLA that you can print stuff with. There's carbon fiber PLA that have carbon fiber infused to make things even stronger. There is even some other different types of filament that are out there, some that we just started carrying called land filament PLA that's actually made from trash in a landfill, and then it's mixed with PLA and then you can print with it. And there's also like old coffee grounds and coffee waste and stuff that can be mixed with PLA to be able to print with that. There's like a reusable biodegradable PLA that might not be like the regular PLA and just have like an extra thing in there. They even have like crazy ones, like aromatic ones that smell like coffee when you print with them, or smell like cinnamon, or roses is another one that's really wild. And there's a bunch of those different types of like PLA composites out there. Yeah?
What about edible filament?
So edible filament is something that is not going to be able to print out of a regular 3D printer that you have in your East class. You want to make your own type of printer to do that. And there's a pancake printer out there that's super awesome that you can look up and you can 3D print your own pancakes. It's pretty awesome and ridiculous. Hershey's working on making their own chocolate printer, like 3D printer that they can make. And there's other like food printers out there that can print pizza and things like that. But why would you not want to try to print food in your 3D printing in your classroom? Would be the biggest thing. Somebody raise your hand. What do you think?
If you use chocolate, it can get sticky and clog up really easily because sometimes it can dry out.
Mm-hmm. It could get really clogged up. What do you think? It could melt it too much. What do you think?
When it comes to, if you have different type of filament, like PLA or ABS, and then you put food in it,
Yeah, exactly. It's mixed in. That's the biggest thing. It's going to be not only going to like gunk up your machine, but it'll get mixed in with the plastic, and you don't want to eat plastic.
They'll have like a dedicated.
Yeah, you need to have a printer that's just for food. And I know somebody who's making one themselves, and they actually, instead of having a heated build plate, he has a cooled build plate. So it's actually like a colder, he has like air conditioner coils in it to make it cool. So when as soon as the chocolate hits it, then it hardens and turns into different things. So you have to do some crazy modifications to make like the edible filament and stuff like that. And there's not really steel filament that you can print with, or something that without having a special machine that can do that. And there are special machines that can print in steel, but they use lasers to turn basically powder into steel. And then they harden the steel into whatever shape that you want. And that's used in industries today, like if you're flying on an airplane, Boeing airplanes, they have 3D printed fuel injectors. So they have 3D printed engines on nearly all the Boeing airplanes now. And so does Airbus. Excuse me, they have a whole bunch too. Of all those like 3D printed engine parts and things like that. So you could print with those different ones, but most of them out of your printer, the best thing is to do a PLA or PLA composite or TPU. That's what we would suggest. And sometimes you can print with ABS, and there's also other filaments that you can use. If you have a heated build plate, then you can print with one that's called ASA filament, and it's made for UV light, made to last outside forever. So if you're going to print something on a sign that's going to be outside, you can print in that filament, and then it won't break down. And you won't have to worry about all those different types of things that are happening with it, and all those things to break down. And another thing that has to go along with that is thinking about a dual extruder versus a single extruder. So is that what do I mean when I say that? Ever heard that before? Maybe? What do I mean?
More than one extruder versus one extruder.
Exactly, on the same machine. Yeah, so if you have a dual extruder one, You can print like 2 different colors at the same time. Or you can print in 2 different materials at the same time. So you could print partially in TPU and partially in PLA. But the thing is, it's really hard to do that. And the biggest way when you're trying to print with that is you have to make sure that the settings for each one of your nozzles is set to what each material that you're using, because they're going to be different settings. So if you're printing with one that you want to be supports and one you want to be flexible, or one that's going to be red and one that's going to be green, you have to make sure that the settings on there are set correctly. And if you're going to do different colors, the best thing that you can do if you have a dual extruder printer is to print with a white wall, which is this wall that will print around the outside edge, and that will stop things from kind of dragging through and mixing all the colors together and all the materials together and stuff like that. And that white wall on the outside can help with a lot of that. But you don't have to have a dual extruder printer to print in tons of different materials. You just have to switch the filament out. And you can actually put codes in the G code, and if you contact us, we can help you with that, to put your code in the G code to say switch the filament out when it gets to this point, and then you swap the filament. So then, like, this part we want to be carbon fiber, so we swap it. And then this part we want to be TPU, so you swap it. Or this part we want to be PLA, so we swap it. And you can move around with those different types of things. But probably the easiest way to print with different types of materials and different types of things is to just do separate prints. So you'll do one print with your flexible material for the part that you want to be flexible, and then the other part that you want it to be solid, you print that with PLA on an entirely different print. So it's a whole different slice, a whole different print on 2 separate things, because you have to have separate models. Same thing if you have 2 different extruders, each extruder has to be assigned to a separate model. So if you were going to have, like, the hand was going to be PLA and each one of the fingers was going to be TPU, you would have to have a separate file for each one of the fingers than you would have for, like, your palm. Then you would have to assign the fingers to one extruder and then your palm to the other extruder. So that's something that you have to keep in mind as well. So those big things with design, you want to think about measuring, making sure that you measure it enough. The second thing is print orientation and making sure you're thinking about the different ways that it's going to print. You want to think about the safety of the model that you're going to have, and then you want to think about the mesh of it as well. So those are the main things you want to think about when you're creating things for 3D printing for each project. So does anybody have any questions about their projects, or about any questions that you might have about a different material or something like that? Yeah, what do you think?
We have a logo 3D printer, and at first it would go, whenever we were trying to print, it would say tip layer. So I thought it was going to be a mixer, and so I fixed
See you guys. Thanks for coming. Doesn't have a sleep mode. Have you tried flashing the firmware or replacing the firmware when you call tech support? No, we don't sell these. We don't sell those, so I'm not really sure. I would just contact tech support or try to Google it, and maybe see if that comes up with an issue. Yeah.
Where you going? Okay.
Actually, can you check for me? I'm not sure.
That tastes gross. It tastes like plastic. Yeah. What's up? No, let's go. See ya.
Oh, okay, here it is.
And don't forget to stop by the booth if you guys want to 3D print something. Come on by. What kind of 3D printer?